Hello. For this problem, we're told that even though the rate varies among individuals, the typical pattern of insulin decrease is to drop by 5% per minute. 25 units of insulin are administered at 7:30 hours. So in this problem, I see that it is dropping, so that's important. It's 5% per minute, and so that is giving me a percentage per a unit of time. I also see that 25 units are administered. Because of the percentage per unit time, I'm going to use a drug breakdown model. So the population at some point in time is the starting population 1 plus r to the t power. You do not need to memorize this. These will be given to you and you have them in your pre-lecture notes at this point. So I want to fill in to write an equation for this scenario. So P of t remains a variable. I will replace P0 with the starting amount of 25. Because the insulin is dropping, I will use a negative with my R. And that 5% does need to be a decimal. So 5 divided by 100 is 0.05. I will also do the math that is inside the parentheses to clean up my formula a little bit. So P of t is 25 times 0.95 to the t power. This is my formula for this scenario. So I move to the second question. How many units will remain at 0735 hours? So looking from the original problem where the insulin was administered at 7:30 exact, this is 7:35. So I see that this is 5 minutes later. So truly I have done subtraction here. 0735 minus 0730 gives me 5 minutes. And so that is my time. And so I'm going to go to my formula, and the population at another point in time is 25 times 0.95 to the exponent of 5. This is calculator friendly, so on my calculator I will type 25 times 0.95. I will use the caret key and put in the exponent of 5. So I'm typing that now, and I encourage you to do the same and make sure you have that typed in correctly. I get an answer here of 19.3. And we were not told here how to round, so if you round it differently, that would be fine. You might even round this to a whole number and say that there would be 19 units remaining. And finally, our third question. This says, when will the patient have only 5 units remaining in their bloodstream? So 2 keywords here. It is asking me when, so that is asking me to solve for t. And it is giving me a population, an ending population, or a population at a different point in time. And so that 5 will fit into the formula and replace the entirety of the P of t. Starting amount was 25. Formula has 0.95 to the t power. So this can be solved by hand using a logarithm, or this can be solved using a graph on decimals. So to use the graph, I have to have equations on both sides. So this is the equation y equals 5. And this is the equation y equals 25 times 0.95. And I'll want to use x in decimals because it uses x and y rather than t. So I pull in decimals, and I want to clear out what I've had before and go ahead and type these in. So the first one is y equals 5. Second equation is 25 times 0.95 to the x power. And I see the blue one is the curve, the red one is the straight line. I see them meet here, and so I see the time is at 31.37 minutes, and that is the x value that I'm seeing there. So my ordered pair from Desmos is 31.37 minutes and 5. This is the x, this is the y, and so the time is about 31 minutes. And again, round based on the directions in your homework. There's no rule to memorize with the rounding. So for this problem, we did all 3 outcomes for the lesson. So outcome 1 is to write a formula, and that's not memorized, but based on the models that we have. Outcome 2 is to use our calculator to figure out a value, which we did. And outcome 3 is to solve for time using a graph or a logarithm. And it is when we have to solve for time that we are using Desmos. The middle step, when we are just figuring out the units or the population, that can be done on our handheld calculator very easily. But when we need to know the time, that is when we want to go to Desmos.